The topic that we're going to be talking about today is authentication and authorization from enterprise API security. It is one of the highly sought after topics today in the world of APIs and API management. So we're going to be looking at some of these different concepts, different topics that are potentially at an introductory level, but goes a little bit deeper. If you are new to the topic, if you're new to the subject of API security, some of these concepts will hopefully help you take the first step in the journey of API security. If you are already aware of some of these things, then hopefully it'll help you take that next step into your API security journey. Jumping right in, let's talk about the digital landscape as it exists today. Now, APIs have become ubiquitous. There is APIs, the heart of most digital products, if not all of the API products that exist today. The conversation has very much shifted away from whether we need APIs or whether we want APIs. It is pretty much a given that your digital product most likely is using APIs to in some capacity. Now the question has now turned into how do we manage APIs better? How do we make APIs production ready? How do we actually look into the world of API security specifically? So while APIs are ubiquitous, what about API security? So here are some statistics that I've sort of managed to gather, and I have the resources available at the end of the presentation as well for you to have a look at yourself. There is a 681% increase in API attacks in the past 12 months. So just for that to sink in, 681%, that is a huge number. And that gives you an idea about A, not only that APIs are being used quite extensively today, but B, which leads to the next couple of stats, which is while 95% of the folks who were polled during this survey suffered an API security incident over the last 12 months. And more importantly, the interesting stat is about 1/3 of those folks lacked any kind of API security strategy. Now, that is a very, very alarming stat to have. So I'm hoping you are not part of those 33% today. But even if you are, at the end of today's session, you'll have at least some introduction, some way for you to get started on your journey of making API security part and parcel of your everyday production or everyday product development lifecycle. So authentication, also known as AuthN, is about identifying or understanding who or what you are, or whether you are who or what you claim to be. Now, notice that we talk about who or what because it can be a user as a person, or it can be a system as well that you might be authenticating. And these can be done in a direct way where you might be applying your own username, password directly, and that is the end of it. Or there might be brokered approach to authentication, which is where your identity providers would come in. Key players in this space would be your Glue and Okta and Curity and Keycloak, for instance, if you've heard of them. We can go into some of those discussions later on as well. Now, authentication also comes with single or multi-factor, as the name suggests. Single factor authentication would be you've got a single thing that you're doing in order to authenticate yourself, and that is it. Multi-factor is usually a combination of few different mechanisms put together to provide a deeper layer of security when it comes to authentication. Now, multi-factor authentication has a few different categories, and typically when we talk about MFA, we are talking about at least 2 out of these 3 categories being worked on together or applied together to make that security possible. So that is something that you know. Now, something that you know may be your username or password, your login details typically, or a PIN number or a PIN code that you might want to add in here, which is basically something that you know. These are things that you may remember or know. The second category is something that you have, and these could be your security certificates or tokens that you may have retrieved, and you have this available to you. And then at the point of authentication, you present the system with it, and then you gain access to the system. That is what we mean by something that you have. And something that you are is typically about the biometric systems. And if you, of course, and we are living in the world of iPhones and Samsung Galaxies, and typically we've seen our thumbprint readers and fingerprint readers and face IDs. All of these are effectively something that you are. They're mechanisms for identifying you based off of your biometric footprint. Now, typically you would, like I said, MFA is all about a combination of 2 or more of these factors. And an example where MFA doesn't really work is if you're looking at a combination of, say, username, password together with a numeric code. as your second layer of authentication. A numeric code that does not change dynamically or is not generated dynamically is something, again, that you are knowing. So those are a combination of something that you know and therefore not quite MFA. So you would want a combination of either, say, a Face ID with a code that is being generated dynamically, or some other combination of those. Moving right along, we come to authorization. Authorization is the process of validating what actions you as an authenticated user or a system can perform once you have been authenticated within the well-defined system boundaries. So authentication done, who you are, this is essentially what you can do, what permissions do you have within the system once you have gained that access. And then finally, we talk about zero trust. And this is really, really come up in a big way, specifically in the enterprise landscape, especially those who are using microservices, where if you really go back to earlier days, you typically, if you talked about network security, we looked at the castle approach to security, where essentially it was hard to breach the defense of the castle, but once you've gained access, after obviously going through the right processes of authentication and authorization, you can gain access to the different resources within the castle walls. However, now with zero trust, that has completely changed, where you're looking at a system where no one is trusted by default from inside or outside the network, and verification is required from everyone or everything that is trying to gain any form of access to the resources on the network. And this is specifically important because when we look at how microservices work, especially in a containerized environment, you're looking at components that are being constantly swapped in, swapped out, scaled up, scaled down. And that means that you don't want to leave any kind of system or any kind of loopholes here where you can potentially open yourself to security risks, because the surface areas typically with microservices is now increased a little bit more than what it used to be before. And of course, if you within a network, the security of your entire system is based off of the weakest component of your overall network. So therefore, the more secure things are, the better it is for you. Now, tokens is a very, very simplistic approach of describing tokens. Is it allows a client to hold some information that can identify the end user and the access that is granted to that client. Now, the objective really is for client that the client does not need to hold any end user's credentials. Now, there's a bit of a caveat to this, especially when we look at some of the different types of tokens. This is definitely true for, say, your access and your refresh tokens. But when we look at, say, the ID tokens that we'll be discussing a little bit, it's a little bit different because you are holding a little bit of information about your end users as well. So we'll dive a little bit deeper into it, but this is sort of a simplified version of what a token tries to achieve as part of your overall security journey. Now, if you really look at an analogy here, the commonly used analogy is usually of a hotel booking that you might have. And so you've already booked a hotel room, and when you get up and it's a day of your check-in, you're going up to the receptionist and you provide some form of an ID for the receptionist to essentially identify you. This could be your passport or your driver's license or any ID of sorts, which is usually a photo ID. And the receptionist will authenticate you, identify for you are who you say you are. And as a response to that, the person is going to give you an access key, which is essentially a token in this case. And that access key will grant you or authorize you to access potentially, of course, your own room. But beyond your own room, you could be accessing other parts of the hotel facilities as well. This could be maybe a VIP lounge. This could be your swimming pools, your gymnasium. It could be any of them, depending on what level of access you are permitted based off the reservation that you have made. So these are all the gym, the house, these are all different, the room. These are all different resources that you want to gain access to. The token makes it possible based off of the different permissions that you have. So this is sort of a bit of an analogy around, how authentication, authorization, and tokens sort of work together. So moving right along, there are also a few different token types. Now, I briefly referred to this previously, so let's look at this. So the most common ones that you would see here, especially around authorization, is access token and refresh token. Access tokens allows the bearer of that token to access an API or access a resource in this case. Refresh tokens are used to obtain a new access token after the original expires. Now, these are usually, both of these are categorized under the authorization flows, and you will see this as part of the OAuth flow that we're going to be going into next. The third type here is the ID token. Now, this comes in once you start looking into OIDC or OpenID Connect, because this is actually more to do with authentication, because you are looking at user identity and user information. So this is a JWT, a JWT, that contains information about the authentication event and user identity. We will see this a little bit more once we go deeper into the world of OIDC and the entire journey around it. Now, one common trope or question around access tokens and refresh tokens is around the time of expiration. Like, how long should an access token be valid for, and how long should a refresh token be valid for? Once again, it really depends on a case-by-case basis. It really depends on what your overall API security strategy is. For the more conservative ones, such as myself, I would usually look at access token expiration being roughly around a minute or so, whereas the refresh tokens potentially anywhere between 5 minutes to a little bit longer. But once again, your strategy might differ from mine, where your refresh tokens might be available for a little bit longer, maybe almost 10 to 15 minutes as well. I've seen longer time periods around this as well. However, again, the ideal situation is you don't want tokens to be available and applicable for very long period of time, because again, once someone gets access to this, they may be able to gain access to your system, and therefore potential risks arise. So that's why access token, refresh token, probably time to live is on the slightly lower side. So what is OAuth? OAuth stands for Open Authorization. And Open Authorization is an open protocol to allow secure authorization in a simple and standard way from web, mobile, and desktop application. It's as simple as it is. It's an open protocol with specific things that it enables and requires you to implement, and that will provide a more standardized way to implement authorization. On to OAuth, I think one of the key things to understand before we dive into the different journeys and different flows is that there are specific roles associated with OAuth. And that is your resource owners, you have your browser or the user agents, you've got your clients, you've got your resource servers, and you've got your authorization and identity servers. And this is a typical sort of interaction diagram, so to speak, in terms of how they all interact with each other. So let's look at each one of these roles before we dive into the different flows and journeys. So within these roles, you've got your resource owner. So this is an entity that grants access to protected resources. As the name suggests, they are the owners of the resource. And more often than not, this is a user, a person, essentially. Now, beyond that, we've got the resource server. This is the server that holds the resources that the resource owner needs access to. And the resource server usually exposes an API, and the entire purpose of open authorization or OAuth is to grant secure access to this particular API. So everything that you're going to be seeing beyond the step is for the resource owner or for the client to essentially gain access to that API from the resource server, to gain access to the resource that we need. Then we've got the client. The client is an application that requests access to protected resources, typically for a resource owner or on behalf of a resource owner. It acts as an agent for them using the application. Authorization and identity servers, they are responsible for accepting credentials from the resource owner, potentially via a client, as you see here up above, and checking if they are authorized to access a restricted resource and providing them with an access token to allow the access. So typically, the way it works is you have your resource owner or the client essentially requesting access to the resource server or the resource themselves. And then the authorization server is going to help you check if they are authorized to gain access to this and grant an access token, which will then, enable you to access those resources with the specific permissions. So that is sort of the different players that we have in this landscape. And once we have that, then start looking at what kind of standardization that we are actually looking to have with OAuth in this space. So obviously the objective here is to provide that standardization, that everyone who's implementing open authorization would have these certain standard practices and certain methodologies that are available to them. And this is makes things a lot more predictable in terms of specifically when you are implementing this within an organization, as well as when you're looking to integrate with systems that are also outside of your organization as well. So if you're secured through this way, you'll be able to handle those different protocols quite easily, or handle those integrations very easily. So two key auth server endpoints that are available as part of OAuth is /authorize, now as well as /token. We'll see both of these in action shortly, but let's just look at what they are all about. So /authorize is used by the client to obtain authorization from the resource server via the user agent redirection. So this is essentially for the client to obtain a form of authorization from the resource owner to say, hey, authorize me, tell me that this is what you are looking to do. This is kind of the information that I need. And based off of the information provided by the resource owner, I can then go back and to the authorization server to gain access. Slash token is used by the client to exchange an authorization grant for an access token. That is, again, the ultimate objective is for us to get that access token. That access token is going to provide the ultimate permission for us to actually use the resources that are underlying. There are also two other concepts here, which is grant types and scopes, which we need to be aware of, especially around OAuth or 2.0. Grant type is the way an application or client gets an access token. There are a few different grant types and mechanisms that we are going to be looking at. There are 4 of those. We're going to be looking at 2 of the most popular ones shortly. Now, scope defines the actions an application or client can perform on an API. Hopefully that is straightforward enough. Now, as far as grant types goes, there are 4 different grant types that exist. We're going to be looking at the 2 most popular ones at the moment, which is starting off with authorization code, also known as auth code. Now, auth code is used by web and mobile applications, typically used when there are human users involved. And it also requires the app to launch a browser to begin the authorization flow to take effect. And we'll see this shortly. So this is a typical authorization code flow that you might look at. There is a step that you need to take before this, and which is kind of missing at the moment. But the step that you need to do before this is to register your application with the authorization server. Now, there are a few different ways of doing this. Typically, how you do it is you have your developer portal, and this is where you're going to be registering your application. There is typically a form that is involved, which you're going to be filling up. And if you are either granted permission automatically or there might be a mechanism for approval. But once approved, what you will get back is a client ID and a client secret, which is what you need as part of your registration process. Once that registration is done, then your authorization code flows can kickstart. And you will see why that is important. So let's kick things off. The first step over here is that redirection from the client or the application back to the browser, which is calling the /authorize endpoints. Is very much the first step that you're going to be taking. There is a couple of things that you're sending as part of information here, which is the response type, which is going to be code, which stands for your auth code. You're also sending the client ID, which you have received as part of your registration process. You're also looking at the redirect URI, which is your which is essentially, I think it's typically the redirection URL here, and a few other information around the scope of what you're going to be looking at, which in this case is read. So once you do that, it will provide a login page, which then the resource owner is going to be providing their credentials if they or have not done so. If they are not previously logged in, this is going to be a place where they're going to be logging in. That login credential will then be sent back to the auth server with those credentials, which will then go back to the browser for the resource owner to provide authorization for the client. And this, you might have seen this in action previously, where, if you're logging in using, say, GitHub, you're logging in using, say, Gmail, for instance, it will request some specific information, which is the consent that you need, that, okay, this kind of information is okay for you to use as part of your overall authorization journey. So it's consent that is required from the resource owner. Once that consent has been granted, that once again goes back to the authorization server, which then goes back to the browser with the authorization code. That authorization code for the final step from the client is then going back to the auth server using the /token endpoint that we spoke about previously. That authorization code is then translated back into the access token, which will then provide you access to the resources that we were after in the first place. It is an 11-step process, as you can see over here, but it's a fairly logical flow that you might be looking at. You may be able to skip some of them if you're previously logged in. For instance, the first couple of segments around step 2, step 3 may or may not be necessary in some cases, but this is sort of the overall journey that you might be taking with your authorization code flow. Once again, the ultimate objective is for you to receive that access token based off of the information, based off the credentials and the grants that have been that has been provided by the resource owner, so that the client can then act with that access token on behalf of that resource owner for accessing resources on an ongoing basis. Moving right along, the next grant type is client credentials. Now, in this case, it's a little bit different from auth code, because in this case, we're talking about applications requesting an access token to access their own resources. And in this case, there are no humans involved. This is typically microservices or machine-to-machine communication, machine-to-machine scenarios that client credentials enables from a security standpoint. Let's look at the client credential flow. It is admittedly a lot simpler when it compares to the auth code flow that we just saw a little while ago, where we are only, and once again, you can see there are a lot lesser number of players here as well. We're only talking about the client. We're only talking about the authorization server in this case, where you start off with sending the client ID and secret using the /token endpoint with the grant type as client credentials, client ID, client secret, and then that will provide you an access token at the end of it. And that is pretty much all that you need to do. Once you've got that access token, once again, the systems can communicate and exchange information securely over the network. So that, in essence, is where we have what we have with OAuth. This is, again, it's a quick introduction into the different journeys of open authorization. However, one thing that you might have noticed here is that open authorization, as the name suggests, is all about the authorization mechanism. It's all about what you can do once you've got access to the system. However, for completion, you also need to think about the authentication mechanism. So that's where OpenID Connect comes in. OpenID Connect, or OIDC, also as commonly known, is an authentication layer that is built on top of OAuth. And what it does, it provides a central point to identify and authenticate end users. It decouples authentication from the client application as well, so you don't have to pair them all together. You don't have to muddle it all together or couple them all together. And it provides basic information about the end user. So this is where you have the ID token that we spoke about previously, which is going to be holding that information about that end user. The 3 types of tokens that we were looking at: access, refresh, ID. This is where the ID token comes in, paired together with the access token as well. So that's a combination that you can be looking at when it comes to OpenID Connect being brought together. Now, if you look at the auth server endpoints, the authorize and the /token endpoints are work pretty much similarly as they did with OAuth that we saw previously, where authorize is still used by the client to authenticate the resource owner via the user agent redirection. The /token is still used by the client to exchange an authorization grant for an access token. What is new, however, in this case is the /user info endpoint. Now, what that does is that it returns claims about the authenticated user when an access token is provided. This is where the authentication aspect comes into play once again. And once again, if you are wondering where OIDC you might have seen or encountered it, anytime that you've seen sign in with specific things or buttons associated with that, sign in with Google or sign in with Facebook, any of those things, it's typically an OpenID Connect or OIDC flow that you might be looking at over there. So now that we've got OIDC as part of our flow, let's see how that sort of changes our authorization code flow that we previously looked into. So at the beginning, the players still remain the same. You've got your resource owner, your browser or client, and the auth server. The initial redirect is still pretty much the same, except in this case, when we're talking about the scope, we're not just talking about scope being a read or write or anything like that. We're talking about the scope being OpenID, which is kind of slightly different from what we had previously. The rest of the journey works very much the similar way, except for all the way at the bottom, where we look at when we are invoking the /token endpoint, we're also invoking the /token endpoint. We are looking at sends when the client is sending the auth code, authorization code. We are not just getting back the access token, but we're also getting back an ID token in this case, which is going to be holding some of the user information. One other thing that I'm mentioning over here is that authorization code flow plus OIDC is often also known as the PKCE, PKCE or PKCE, which is proof key for code exchange, common terminology that is used to sort of identify or denote this particular flow. This is also another simplified version of what we've been talking about, but this in essence is the key difference when we build OIDC on top of OAuth, especially with the authorization code flow. The key difference here is that you're not just getting access token, you're also getting some user information here through the ID token. Let's talk about TLS first. Let's start off with TLS. So TLS is transport layer security. What it does is it authenticates the server in a client-server connection. Now, I'm absolutely 100% sure you've already seen this in action, because anytime you've seen or visited a website which has an HTTPS certificate associated with it, that little lock symbol that you see on your browser on Chrome, that is using TLS. That is essentially authenticating the server in a client-server communication using TLS over there. There are specific components or specific things associated with TLS here, which is that there is a public key encryption that you have, which means that anything that is encrypted with a public key, and typically you've got a combination. You usually have a public key as well as a private key. And typically anything that is encrypted with the public key can be decrypted only with a private key, and vice versa. So anything that has been encrypted with a private key can only be decrypted by the associated public key here. So that is one of the specificities of TLS. The other part of this is a TLS certificate. Now, a TLS certificate is a data file that contains a public key, a statement of a certification or certifying authority, and an expiration date to verify a server's device's identity. Now, one important thing over here is that the certifying authority, or CA as it's known, is typically a third party. It's typically not the organization themselves trying to authenticate or authorize themselves. It's not themselves trying to say that, yeah, our mechanism is done. There are self-certifications, but typically when you're talking enterprise level TLS, you're looking at a third party who's going to be doing the signature. And we'll see an example of this really, really shortly. The final component of this is the TLS handshake, which is essentially the process of verifying the TLS certificate and the server's possession of the private key. Now that we've got TLS, what is mTLS? mTLS, or mutual TLS, ensures that the parties at each end of a network connection, your client and your server, are who they claim to be by verifying that they both have the correct private key. So in TLS, it's typically the client requesting is the one who's verifying the server's certificate, and the server is the one who's presenting with the TLS certificate. With mTLS, it's essentially a two-way process where both the client and the server will be doing this. And this is a representation of that. You start off with the client connecting to the server, and the server presenting the TLS certificate. The client then verifies that server certificate, and then the communication channel has been established and they can exchange data over their encrypted TLS connection. With mutual TLS, of course, there are a couple of more steps, because after the server presents a TLS certificate, which the client verifies firstly, the client also subsequently presents the TLS certificates of its own. The server verifies this and grants access to its resources, and the communication has been established and they can communicate, exchange data happily ever after for a limited period of time, I believe. But as long as the communication channel is open, they can do that. Now, finally, we talk about some access control mechanisms. Again, things that you might have come across, things that you might come across as you delve into the world of API security. Starting off with probably the simplest mechanism here, which is the access control list, or ACL. ACL is basically a list of rules that specifies which user or system is granted or denied access to a particular object or system resource. It's a list. If you're on the list, you get access. If you're not on the list, bad luck. So that is basically what ACL is all about. Then you've got your role-based access control, also known as RBAC. This is a security paradigm that allows users to have restricted access to resources based on the roles in an organization. As an example, within an organization, you may have roles as a developer, you may have roles as quality assurance specialists or product owners, even your account managers. You can have your DevOps, you can have your DevSecOps, all of these different roles requiring different access or different things that they might want to, or different ways in which they might be interacting with your system. This will provide them with that specific access and opportunity to interact with your system in a secure manner. And really, when we talk about access control, it's not about restricting access specifically, but also empowering and encouraging people to actually use your system without the fear of potentially breaking it down by a single action. that you take. So that's kind of the big role of why you should have access control policies in place within your organization. It's not just about restricting access, but it also encourages and enables people to do things that they are meant to do and restrict them from doing things that they are not. And as an extension of the role-based access control is attribute-based access control, also known as ABAC. Now, ABAC is an authorization model that evaluates the characteristics or attributes of an entity instead of purely just the roles to determine access. This can go beyond just the roles that you might have. This can be based off of geographical location. This can be based off the time of day or time of access that you might have. And based off of that, you may have different degrees of access to the systems that you might want access to. So that is the end of sort of the different authentication and authorization mechanisms and methodologies that I wanted to share with you today.